In science fiction, many tropes and patterns are repeated through the decades. They have become symbols and acquired an iconic status, and sci-fi will just not be the same without them. A lot of these tropes date back to a time before we had direct observations of things smaller than moons, before we had radio astronomy, radars, space telescopes, and before we could look at the universe throughout the entire electromagnetic spectrum. They are what we believed to be true back then, but today we have discovered so much more. My goal with this series is not to tear down those tropes and obliterate them from science fiction, and indeed I do not look down on those who have, and in fact those who will consciously use these tropes in the future. Sometimes story is so much more important than accuracy that it would anyway be a crime to remove them, plus the visuals they provide can be absolutely amazing. However, my intention is to bring future authors and creators out of the 1960s pulp magazine and up to date with our current, slightly better understanding of physics in the universe, and show them how we can modify these tropes to bring them in line with reality without sacrificing any of the coolness that stems from them, as well as to bring their attention to new discoveries and phenomena that open even more opportunities for storytelling through new challenges, new tools, and new settings where our stories can take place in. So, I want to start with a pet peeve of many an astronomer: asteroid fields. Asteroid fields are a cornerstone of action in space. Typically, scenes with asteroid fields involve ships dodging between asteroids at high speeds, usually during a pursuit. The asteroids are invariably depicted as large and packed tighter than students on a 40-year-old bus during rush hour in my undergrad. Today, we know that this is not the case. Asteroid fields are very sparse. There are plenty of kilometers between the asteroids, and intense maneuvering is really not needed. In fact, to hit an asteroid, you would generally have to be aiming for one. However, we do not have to sacrifice our fast-paced chases between large space rocks. We only need to move them to a different real-life setting. We like to think of planets and moons as these gigantic solid objects. However, just like a mountain is composed of multiple rocks and layers, so are planets and moons. And when something beats their gravity at a game of tug of war, they don't handle it very well, and they may suffer a physical or emotional breakdown. A planet or a moon that has broken apart is an excellent candidate to replace an asteroid field. But how do these objects break apart? This is typically when they come too close to the body they're orbiting, a body that is much larger and more massive than them. When they cross what is known as the Roche limit, the gravity of the other body combined with the rotation of the planet or moon in question is enough that the gravity of the planet can no longer hold its outer layers together. The parts nearer the main body will start traveling slightly faster, and the parts further away will fall behind. As the planet loses mass, its gravity weakens further, and it will further disintegrate. The pieces of the planet or moon are going to eventually form a ring around the primary object. While the ring will tend to become more homogeneous over time, I believe the best moment for a chase between space rocks is just shortly after the planet has broken apart, where the innermost core can still be hot and glowing, and the larger chunks have not completely disintegrated yet do provide a lot of variety to the size of the debris. Another option is a collision between two bodies. This will generally leave most of the larger one in one piece, while the smaller one may form a moon or a ring around it. So next time I see a chase in space, I hope to hear the characters refer to the environment as a broken up planet or moon instead of a suspiciously crowded asteroid field. And as a bonus, the debris field can evolve through a longer story, starting as a planet that's just now breaking apart, going through the phase of being irregularly distributed around the main body, and eventually ending up in much smaller chunks, forming a more even ring around it over the decades. The other very common trope I would like to address is nebulae, or nebulas, or something like that. These are depicted as space clouds, however, their properties are vastly exaggerated or entirely made up. Their typical effects include obscuring vision or blocking sensors and disrupting shields. The latter two typically are explained through electromagnetism or, more abstractly, plasma in the nebula. Plasma is atoms stripped of their electrons and is indeed charged. However, there is no locally strong electric field inside the nebula, not at a gradient that would be noticeable to a spacecraft that's not specifically looking for something so sensitive. It is in fact very homogeneous, unless such a field is generated by a star or some other object carrying its own localized field independently of the nebula, in which case that should be the focus of the environment, not the nebula. In addition, while nebulas are visible sometimes to the naked eye, if just barely, you should not expect that being inside a nebula, much more chasing an enemy inside the nebula, is going to obstruct vision. Earth's air density is about 10 to the 19 molecules per square centimeter. That is a million times a million times a million times 10 molecules in one cube of about 1 centimeter on each side. A vacuum created on Earth inside the vacuum chamber or other environment, like the vacuum testing facilities for satellites, has about 10 to the 5th to 10 to the 7th molecules per cubic centimeter. That is 100,000 to 10 million. The densest of nebulas, however, can have densities of 10 to the 4th molecules per cubic centimeter, which is about 10,000. That is not to say that denser nebulae cannot exist, however, they would not be common. The nebulas that we do see are light years thick, and so there are light years of material stacked in a straight line producing the light that reaches us. Even so, they still maintain a degree of transparency, and we can still see objects behind them. Thus, hiding a spacecraft inside a nebula is about as effective as hiding a lit lantern behind a large window. Does this spell the doom of the trope, though? No, it does not. Once again, we have to shift the focus to a different location, and in the process solve a couple of other plot holes with nebulas. And we have accretion disks to the rescue. An accretion disk is a spinning disk of matter, dust, spinning around a forming star. These disks start out as dense disks with a gap opening slowly in the middle. As the star gathers more material, the gap opens up, and the disk becomes a bit more ring-like, and it becomes a protoplanetary disk, where planets form. And eventually all the dust is collected by the star or the planets or the asteroids forming the inner system, and the disk dissolves. These disks are visually opaque, meaning something could hide on the far side or even inside the disk. Additionally, if the disk is old enough that planets may have started forming, these planets can have a magnetic field, and these magnetic fields could interfere with sensors, in combination with the thick dust of the protoplanetary disk. An additional problem that protoplanetary disks solve is scale. Even traveling at warp speed, i.e., a handful of times the speed of light, it should take hours to cross the distance of one solar system. The edge of a nebula should not be a wall that is crossed, but rather should have a blurred out fuzzy ending, only gradually becoming denser. By contrast, such a protoplanetary disk is about the size of a solar system and reasonably thin. It is much more plausible that a spacecraft could dip in and out of said disk in a matter of hours or even minutes, allowing these quick evolutions in the plot where ships are hiding and reappearing to be done in a realistic manner. Another bonus of the protoplanetary disk or accretion disk is the existence of asteroids and planetesimals inside it. Although these would be sparse, it is narratively conceivable that a starship could hit one in its relatively opaque medium when traveling at relativistic speeds. Though I would recommend you describe a narrow dodge instead, as I would bet more money on surviving a meteor strike than a fender bender with an asteroid. So, nebulas and asteroid fields are two of the most common and oldest tropes in science fiction, specifically in space. And although we now know that they are not how our predecessors imagined them, the core concept and plot devices that came with them need not be sacrificed to the altar of realism. Instead, we only need to correct them a little bit to show the attention to detail and make a story scientifically plausible by our modern scientific understanding. I hope that you found this interesting and informative, and that you will incorporate this knowledge in any story or setting that you happen to be creating, working on, involving chases and hide and seek in space. And if you're not writing or creating something, I sincerely encourage you to try it, even if you never share it. It's a very rewarding experience. I hope to see you next time when I will be talking about radiation and space weather and the smorgasbord of dangers that this poses to both humans and machines in space. Indeed, in that video you will find a lot of plot hooks and opportunities for new narratives that have scarcely ever been explored in sci-fi. I will also touch on personal experiences with space weather effects while working on a satellite. If you enjoyed this video and would like to let me know, I will greatly appreciate it if you hit the like button so hard that debris forms rings around it. You can also subscribe to get notified when the next video is coming as you navigate any opaque protoplanetary disks in your general vicinity, as I do not have anything even remotely resembling a guess at the upload schedule. And I will be delighted to take requests in the comments for specific topics to cover or something you would like to hear more about in depth in a separate video on that topic. Until our next journey, farewell.